Good morning, students. Students, in previous class we have discussed about some questions whether they are 1 1 or onto. 1 1 ಆಗಿದೆಯಾ onto ಆಗಿದೆಯಾ ಅಂತ ಅನ್ನೋದನ್ನ ಕೆಲವೊಂದು ಫಂಕ್ಷನ್ ಸ್ಪೆಷಲಿ f of x equals x square ಅಂತ ತಗೊಂಡ್ವಿ. x square ಅಂತ ತಗೊಂಡು ಅದನ್ನ ನಾವು ಡಿಸ್ಕಷನ್ ಮಾಡಿದ್ವಿ. f of x equals x square ಅಂತ ಅನ್ನೋದು ನ್ಯಾಚುರಲ್ ನಂಬರ್ಸ್ ಟು ನ್ಯಾಚುರಲ್ ನಂಬರ್ಸ್. when n tends to n ಅಂತ ಆದಾಗ ಮಾತ್ರ ಅಲ್ಲಿ 1 1 ಆಗುತ್ತೆ. Otherwise it is not onto for natural numbers. For especially for integers and rational numbers, z tends to z ಅಂತ ಹೇಳಿದಾಗ q tends to q ಅಂತ ಹೇಳಿದಾಗ it is not 1 1. ಯಾಕೆ ಅಂತ ಆದ್ರೆ ಈಗ f of -2 ಅಂತ ತಗೊಂಡ್ರು x square 4 ಬರುತ್ತೆ. f of +2 ಅಂತ ತಗೊಂಡ್ರು 2 square 4 ಬರುತ್ತೆ. -2 +2 both having the same image 4 ಬರುತ್ತೆ. For two different elements of the first set having the same image in the second set anta helidaga it is not 1 1. It is not 1 1 because 1 1 function ge definition all the elements of the domain having the different images iddaga matra adanna 1 1 anta heltivi. Now here I will take one more example, one more question to check whether it is 1 1 onto 1 1 and onto. So here function n tends to n given by f of x equals x cube. f of x equals x cube. So friends, ega na em marana, now just let me take the set natural numbers anda ond kade tagothe nodi. General discussion I will take that is n here and n here. Okay, I take the natural numbers here 1, 2, 3, 4, etc. These are all the natural numbers, and I take here also the natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Here if you substitute 1 here, 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64. But listen to me, notice 1 ge 1 bantu, 2 ge 8 bantu, 3 ge. So totally all the elements of the natural numbers have different images. Therefore it is 1 1. It is 1. Okay, it is 1 1. But all the elements of the second set are not images. Second set nalli iro ella elements image ಆಗ್ತಾ ಇಲ್ಲ. ಹಾಗಾಗಿ ಇದು onto ಆಗಲ್ಲ. ನೋಡಿ ಈಗ ನಾನು again I am going to clear that point with respect to the function whether it is 1 1 or onto. 1 1 onto ಗೆ difference ಏನು? First set ನಲ್ಲಿ ಇರೋ ಎಲ್ಲಾ elements ಗೆ different images ಇದ್ರೆ ಅದು 1 1 ಆಗುತ್ತೆ. Second set ನಲ್ಲಿ ಇರೋ ಎಲ್ಲಾ elements image ಆಗಿದ್ರೆ ಅದು onto ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಇಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ ಗೆ 1 ಗೆ 1 ಇಮೇಜ್, 2 ಗೆ 8, 3 ಕ್ಯೂಬ್ 27, 4 ಕ್ಯೂಬ್ 64, 5 ಕ್ಯೂಬ್ 125, 6 ಕ್ಯೂಬ್ 216, 7 ಕ್ಯೂಬ್ 343. Totally they are all having different images. Therefore it is 1 1. But here 1 image, 8 image, totally cube numbers ಅಷ್ಟೇ ಇಮೇಜ್ ಆಗುತ್ತಿಲ್ಲ. But 2, 3, 4, 5, 6 they are all not images. Therefore it is not onto. Here it is very clear. It is 1 1 but not onto. But ಇಲ್ಲಿ ನಾವು ಏನು ಮಾಡಬೇಕಾಗುತ್ತೆ, ಇದನ್ನ ನಾವು ಹೀಗೆ ಎಕ್ಸಾಮ್ ನಲ್ಲಿ ಬರೆಯೋ ಹಾಗಿಲ್ಲ. But how to express this? I take here f of a equals f of b. Okay, now here f of a means a cube. Here f of b means b cube. According to the theory of indices, when the bases are same, powers are also same. When the bases same, the powers same, and the powers same, then the powers same, then bases are also same. Therefore here a equals b. Therefore f is 1. F is 1. ನೋಡಿ ಇಲ್ಲಿ 1 1 ಬಂತು ಅದನ್ನ ಹೇಳಿ. Okay, now here, now I take B is equal to f of A. Procedure, we should follow this procedure. B is equal to f of A. B is equal to f of A. F of A means if you substitute A here, then it will become A cube. A cube. Then what is A? A is equal to cube root of B. A is equal to cube root of B. But cube root of B, ಇಲ್ಲಿ ನೋಡಿ cube root of B ಅಂತಂದ್ರೆ this is the B element here. 1 cube we know that 1, but 2 cube we have actually 2 cube, but that not belongs to the number. What you will get for 2 cube, that number not here. 3 cube not belongs to natural number. 4 cube not belongs to natural number. Of course 1 cube is there. 8 cube is there. Then cube root of 8 is there. Cube root of 27 is there. Cube root of 125 is there. But cube root of 2 is not here. Cube root of 3 not here. Cube root of 4 not here. Cube root of 5 not here. Okay. Totally here it is not belongs to natural number. Some numbers are only belongs to natural numbers. But all numbers, cube root of all numbers not belongs to natural numbers. Therefore, f is not onto. F is not onto. Therefore, the given function is 1 1 but not onto. It is very clear. Notice, this is the procedure for 1 1. This is the procedure for onto. But what you will get the number if it is belongs to the given set. Kottiro number, kottiro set ge, which if it is belongs to the given set, then only it is 1. Then only it is onto. Okay? ಅದಷ್ಟು ಅಲ್ಲ. ನೀಟಾಗಿ ನಾವು ಏನು ಡಿಸ್ಕಷನ್ ಮಾಡಿದೀವಿ ಆ ಥಿಯರಿ ಪಾಯಿಂಟ್ ಅನ್ನ ಆ ಥಿಯರಿ ಪಾಯಿಂಟ್ ಮೇಲೆ ನಾವು ತಗೋತಾ ಇರೋ ಎಕ್ಸಾಂಪಲ್ಸ್ ಕರೆಕ್ಟ್ ಆಗಿ ಆಗಲ್ಲ. ಅದನ್ನ ಚೆಕ್ ಮಾಡಿ. ಓಕೆ? ದಿಸ್ ಇಸ್ ದ ಥಿಂಗ್. ನೌ ಹಿಯರ್ ದ ಸೇಮ್ ಕ್ವೆಶ್ಚನ್ f of x equals x cube for f. ಇದು ನೋಡಿ ಇದು f z tends to z given by f of x equals x cube. f of x equals x cube. ನೋಡೋಣ ಈಗ ನಾನು ಪ್ರೀವಿಯಸ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ಆನ್ಸರ್ ಮಾಡಿದ ಹಾಗೆ ಇಲ್ಲೂ ಹಾಗೇನೆ z I take the integers here integers minus 2 minus 1 0 1 2 etc. Here also z, here also z. Minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Now listen to me here. For minus 2 whole cube, minus 2 whole cube, minus 8, minus 1 whole cube, minus 1, 0 whole cube, 0, 1 cube, 1, 2 cube, 8, 3 cube, 3, 27. ನೋಡಿ ಈಗ minus 2 ಗೆ minus 1, minus 8 ಬರುತ್ತಿಲ್ಲ, minus 1, 0, 0, totally z integers ಗೆ ಫಸ್ಟ್ ಸೆಟ್ ನಲ್ಲಿ ಏನು ಎಲಿಮೆಂಟ್ಸ್ ಇದೆಯೋ ಅಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ಗೆ ಡಿಫರೆಂಟ್ ಇಮೇಜಸ್ ಸಿಗ್ತಾ ಇದೆ. All the elements of the first set having the different images in codomain. ಹಾಗಾಗಿ ಇದನ್ನ 1 1 ಅಂತ ಹೇಳ್ಬೋದು ನಾವು. Yes, definitely it is 1 1. But onto, is it onto? No. Why it is onto? Because minus 2 is not image, 2 is not image, 3 is not image, then minus 3 is not image, minus 5 is not image. Totally all the elements of the codomain are not images. Okay, some elements of the codomain only they are the image, but if all the elements are not images, then it is not onto. Illi ella elements unno codomain nalli andre second set nalli iro elements ellavu image agde irodrinda idu onto aagta illa, therefore it is not onto. But here it is not procedure, we are not supposed to show like this. This is just ಏನಂದ್ರೆ ನಮಗೆ ಒಂದು ಸೆಟ್ ಹೇಗೆ ಡೊಮೈನ್ ಆಗುತ್ತೆ ಹೇಗೆ ಕೋ ಡೊಮೈನ್ ಆಗುತ್ತೆ ಅಂತ ಅನ್ನೋದಕ್ಕೆ ಜಸ್ಟ್ ಅಲ್ಲ. But procedure is first you should take like this, f of a is equal to f of b. F of a is equal to f of b. Then if you substitute a here, a cube, then b cube. Then when the powers are same, bases are same. Therefore f is 1 1. F is 1 1. Then b is equal to f of a. B is equal to f of b is equal to a cube. Then a is equal to cube root of b. It is not belongs to z. It is not belongs to z. ಬೇಕಾದ್ರೆ ನೋಡಿ ಒಂದಷ್ಟು ಎಕ್ಸಾಂಪಲ್ ಬರೀತೀನಿ. Because cube root of -3, cube root of 3, cube root of 5, they are all not belongs to z. Not belongs to z. Therefore f is not onto. F is not onto. F is 1 1. F is 1 1, but not onto. The given function is 1 1, but not onto. This is the question. Z tends to z. Z tends to z. F of x equals x cube. What totally? F of x equals x cube anta helidaga. Listen to me. Now f of x equals x cube anta helidaga. For this, it is very important. Listen to me carefully. For m tends to n, z tends to z, and q tends to q. Q tends to q. For all this, 1 1, yes, onto, it is not onto. For all n tends to n, z tends to z, 1 1 ಆಗುತ್ತೆ. For q tends to q, 1 1 ಆಗುತ್ತೆ, but onto ಆಗಲ್ಲ. For f of x equals x square, f of x equals x square only for natural numbers to natural numbers. N tends to n, 1 1, but not onto. Then z tends to z, q tends to q. For all, it is not 1 1 and onto, not onto. Okay, x square for f of x equals x square. F of x equals x cube. N tends to n, z tends to z, q tends to q. 1 1 ಆಗುತ್ತೆ, onto ಆಗಲ್ಲ. Right? This is the answer. Next question. So now here, let me take two examples, two questions, very important questions. I will take two questions with respect to greatest integer function as well as modulus function. I will take one question. Prove that the greatest integer function, f, so as r tends to r, f r tends to r given by f of x equals here greatest integer function x is neither 1 1 nor onto, neither 1 1 nor onto. Okay, now here, listen to me. This is greatest integer function. For greatest integer function, I will take the r tends to r here. F r tends to r. R tends to r means we can take any numbers here, integers, natural numbers. So any. So here actually real numbers. That real numbers to real numbers, whatever it is, you can take any natural numbers, integers, and rational numbers. Whatever it is, you can take any numbers. Now here, I will take f of x equals here modulus x. I mean greatest integer function. Now I will take here f of 2.1. It is equal to greatest integer function of 2.1. I mean this one here, f of 2.1, it is 2, greatest integer function. F of 2.2, it is 2. Then f of 2, it is also 2. Okay. Now listen to me. Here f of 2.1 is 2. F of 2.2 is also 2. F of 2 is also 2. Okay. But here, listen to me. For here, I take f of minus 3.1. It is minus 3. F of minus 3.2. It is also minus 3. Here, listen to me. I will take the conclusion part here. Listen to me carefully. For all rational numbers here, for all the elements of the domain having the same image here, for 2.1, 2.2, 2, like this, here it has the same image here. For 3 different elements I have taken, for all 3 different elements having the same image 2 here. Here also I have taken 2 different elements of the domain having the same image minus 3, minus 3. Therefore, it is not 1, 1. Here, 3 different elements have the same image, 2 different elements have the same image. Therefore, it is not 1, 1. Not 1, 1. And also here, we have only the integers. Integers are the images here. Minus 1 is the image, minus 2 is the image, 0 is the image, 3 is the image, 5 is the image, 5 is the image. But here, but rational numbers are not images here. Okay. Now here, again I repeat, here all the elements here, all the elements of the domain have not different images. Therefore, f is not 1. Okay. And all the elements which are rational numbers, are of codomain are not images. Therefore, f is not onto. So here I take here for 3 different images, for 3 different elements having one image. It means all the elements of the first set, all the elements of the domain are not having different images. Therefore, it is not 1, 1. But in second set, actually in second set, all integers are images. All elements, all integers, minus 2, minus 1, 0, 1, 2, 3, etc. These are all images. But all rational numbers are not images here. 2.1, 3.1, 3.8, 5.0, 8.1, they are not images here. They are all not images. Therefore, f is not onto. This is related to greatest integer function. So here, just keep it in your mind, the greatest integer function, it is not 1, 1 and not onto. Neither 1, 1 nor onto. Therefore, the greatest integer function f of x is equal to greatest integer function is neither 1, 1 nor onto. Right? So here, now I take for modulus function. Modulus function, here f of x, so as r tends to r, or z tends to z, r tends to r, R tends to R, given by f of x equals modulus x. Modulus x. Check the function is 1 1 or R. 1 1 or on. Okay. Otherwise, show that show that the function. No, ಇಲ್ಲಿ ನೋಡಿ ಈಗ ನಾವು ಇದಕ್ಕಿಂತ ಮುಂಚಿನ ಕ್ವಶನ್ ಅಲ್ಲಿ ಗ್ರೇಟೆಸ್ಟ್ ಇಂಟೀಜರ್ ಫಂಕ್ಷನ್ ನ ತಗೊಂಡ್ವಿ. ಗ್ರೇಟೆಸ್ಟ್ ಇಂಟೀಜರ್ ಫಂಕ್ಷನ್ 1 1 ಆಗಲಿಲ್ಲ, on 2 ಆಗಲಿಲ್ಲ. ಗ್ರೇಟೆಸ್ಟ್ ಇಂಟೀಜರ್ ಫಂಕ್ಷನ್, signum function, modulus function. These three functions are very important. ನಿಮಗೆ ಫಸ್ಟ್ PU ನಲ್ಲಿ ಇತ್ತು. ಫಸ್ಟ್ PU ನಲ್ಲಿ 5 ಮಾರ್ಕ್ಸ್ ಗೆ ಒಂದು ಕ್ವಶನ್ ಕೇಳ್ತಾ ಇದ್ರು. Define signum function, define greatest integer function, define modulus function and write its domain and range ಅಂತ ನಿಮಗೆ 5 ಮಾರ್ಕ್ಸ್ ಗೆ ಕ್ವಶನ್ ಇತ್ತು. ಬಟ್ ಇಲ್ಲಿ ಸೇಮ್ ಕ್ವಶನ್, ಸೇಮ್ ಕಾನ್ಸೆಪ್ಟ್, ಬಟ್ ಆರ್ ಡೊಮೈನ್ ರೇಂಜ್. ಡೊಮೈನ್ ಅಂದ್ರೆ ಫಸ್ಟ್ ಸೆಟ್, ರೇಂಜ್ ಅಂದ್ರೆ ಸೆಕೆಂಡ್ ಸೆಟ್ ನಲ್ಲಿ ಬರೋ ಎಲಿಮೆಂಟ್. ಸೆಕೆಂಡ್ ಸೆಟ್ ನಲ್ಲಿ ಬರೋ ಎಲಿಮೆಂಟ್ ಅನ್ನ ರೇಂಜ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಬಟ್ ಕೋಡೊಮೈನ್ ಅಂತ ಅಂದ್ರೆ ಕಂಪ್ಲೀಟ್ ಸೆಕೆಂಡ್ ಸೆಟ್. ಓಕೆ, ಸೊ ಇದು 1 1 on 2 ಆಗುತ್ತಾ ಈ ಫಂಕ್ಷನ್ ಗೆ ಅದನ್ನ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ ನಾವು. ಸೊ ಹಿಯರ್ ಮಾಡ್ಯುಲಸ್ ಫಂಕ್ಷನ್ R tends to R. Let me take now, listen to me here. ಈಗ ನೋಡಿ ಇಲ್ಲಿ ಜನರಲ್ ಆಗಿ ತಗೋಣ. Here I will take some examples here. Here f of minus 2, it is equal to 2. F of 2, it is also 2. So here f of minus 3.5 is equal to 3.5. F of 3.5, it is also 3.5. Okay, f of minus 2 is 2, f of 2 is 2. F of minus 3.5 is 3.5, f of 3.5, 3.5. Listen to me, two different elements of the domain has same image. Here minus 2 and plus 2 has the same image. Here two different elements of the domain has same image. Therefore, it is not 1 1. I will write here. This is the rational number. This is the real number and this is the real number. I take here, etc. Minus 2, minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. I take the integers here. So minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, etc. Listen to me here. For minus 3, plus 3, minus 2, plus 2, minus 1, plus 1, 0, 0, 1, 1, 2, 2, 3, 3. Here, both minus 1, 1 has the same image 1, 0 has 0, and the minus 2 has the same image. Like here, two different elements of the domain has same image. Therefore, it is not 1 1. When we will come to the point of onto ge bandaga, listen to me, all the positive integers, all the positive elements of the domain, codomain are only the images, but the negative elements, negative numbers are not images. Therefore, it is not onto. Now here, I write here two different elements have the same image. Therefore, f is not 1. F is not 1. All the elements, all the negative elements are not images. Therefore, f is not onto. Better have to write like this. So this is here, the two elements have the same image. Therefore, the two different elements have the same image. Therefore, f is not 1 1. all the negative elements are not images. Here the first set, here the second set. The first set, in a first set, the two different elements have the same image. Therefore, F is not 1, 1. But in second set, all the elements are not images. All the elements, I mean, all negative elements are not. All negative numbers, negative elements. What? It has the negative elements. These are all not images. Not images. Therefore, F is not on. Now, one more important question. Already we discussed about that greatest integer function and modulus function. But both the functions, neither 1, 1 nor not. Now, let me take one more important function, that is Signum function. We know that in a Signum function, we know that for all negative numbers associate with minus 1. 0 is associated with 0. And for all positive numbers, they are all associated with plus 1. Now here, this is the Signum function. F of x equals 1 if x greater than 0. X greater than 0 means f of x equals 0, then f of x equals 1, it is 1. F of x equals 2, it is 2. For all positive numbers, it is 1. If f of x equals 0, then it is 0. F of minus 1 is equal to minus 1. F of minus 2 is minus 1, minus 1. For all negative numbers, it is equal to minus 1. Okay. Now here, it is very clear, it is neither 1, 1 nor not. How it is, just we are going to show that how it is neither 1, 1 nor not. Now here, I take for all negative numbers here. Here, f of minus 1 is equal to minus 1. F of minus 2 is equal to minus 1. F of minus 3 is equal to minus 1. Then f of 0 is equal to 0. Then f of 1 is equal to 1. F of 2 is equal to 1. F of 3 is equal to 1. So here, listen to me. Now here, for all negative integers have the same image. For all positive integers have same image. Okay. Therefore, it is not 1, 1. Nodi iga ella different images aithe nodi, different elements aithe. So here, for all negative elements of the domain have same image minus 1, and all positive elements of the domain have the same image. Okay. In a domain, all negative elements have the same image minus 1, and all the positive elements of the domain have the same image, that is plus 1. Therefore, F is not 1. F is not 1. F is not 1. Now I take for onto part. In onto, you know, here we have the range. We have the range only 3 numbers. Minus 1, 0, 1. That's all. Apart from minus 1, 0, 1, the remaining elements are not images here. Nodi iga R tends to R. R tends to R anta helidaga, ee first R nalli baro all negative elements ge minus 1 barutte, all positive elements ge plus 1 barutte. All negative elements same image, all positive elements, positive numbers same image irodrinda 1, 1 agalla. So ಈಗ next second set R. ಈ R ನಲ್ಲಿ just -1 0 1 ಅಷ್ಟೇ ಈ 3 ಅಷ್ಟೇ ಇಮೇಜ್ ಆಗಿರೋದ್ರಿಂದ they are only the images. Now here the range of the Signum function -1 0 1 they are only the images. Other elements are not images. Therefore F is not on. Therefore Signum function is neither 1 1 nor on 2. So listen to me students, ಏನು ಇಷ್ಟೊಂದೆಲ್ಲ ಬರೆದ್ರಲ್ಲ ಸರ್, don't confuse here, just think that concept. ಆ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ 1 1 ಅಂತ ಅಂದ್ರೆ ಏನು, on 2 ಅಂತ ಅಂದ್ರೆ ಏನು, 1 1 for the given function whether it is 1 1 or on 2 ಆಗುತ್ತಾ ಆಗಲ್ಲ. ಹೇಗೆ 1 1 ಈ ಫಸ್ಟ್ ಸೆಟ್ ನಲ್ಲಿ ಇರೋ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಗೆ ಡಿಫರೆಂಟ್ ಇಮೇಜಸ್ ಬರುತ್ತೆ, ಸೆಕೆಂಡ್ ಸೆಟ್ ನಲ್ಲಿ ಇರೋ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲವೂ ಇಮೇಜಸ್ ಆಗುತ್ತೆ. ಈ ತರದನ್ನ ನೀವು ಚೆಕ್ ಮಾಡಿ. So this is one of the important question whether, so here totally ಈಗ ನಾನು 3 functions ಹೇಳಿದ್ದೀನಿ. ಒಂದು greatest integer function, modulus function and signum function. greatest 3 functions 1 1 ಆಗಲ್ಲ, on 2 ಆಗಲ್ಲ. ಸುಮ್ಮನೆ neither 1 1 nor on 2 ಅವರೇ ಹೇಳಿದ್ದಾರೆ ಅವರು. signum function show that neither 1 1 nor on 2, it is not 1 1, it is not on 2, ಸುಮ್ಮನೆ ಬರೆಯೋದು ಬೇಡ. ಬಟ್ ರೀಸನ್ ಏನು, ಅದಕ್ಕೆ ಏನಕ್ಕೆ 1 1 ಆಗೋದಿಲ್ಲ, ಏನಕ್ಕೆ on 2 ಆಗೋದಿಲ್ಲ, why it is not 1 1, why it is not on 2, just we should give the reason. Okay, this is one of the important question. Now so here let A, set A 1 2 3, B 4 5 6 7 and the function is given. Let the function 1 4 2 5 3 6 be a function from A to B. Show that f is 1 1 but not on 2. It is given here. This is the function. It is very simple. Here actually 1 2 3 they are the elements of domain. This is codomain. But ಈಗ ನೋಡಿ codomain ನಲ್ಲಿ ಇರೋ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಇಮೇಜ್ ಆಗಿದ್ರೆ on 2 ಅಂತ ಹೇಳ್ತೀವಿ. ಫಸ್ಟ್ ಸೆಟ್ ನಲ್ಲಿ ಇರೋ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ ಗೆ ಡಿಫರೆಂಟ್ ಇಮೇಜಸ್ ಇದ್ರೆ ಅದನ್ನ 1 1 ಅಂತ ಹೇಳ್ತೀವಿ. Now here 1 has 2, so 1 has 4, 2 has 5, 3 has 6. I write here actually A, this is B. Now here A, this is B. Okay, for 1 2 3, here 4 5 6 7. Now here for 1 associate with 4, 2 associate with 5, 3 associate with 6. Listen to me now here. All the elements of the domain have the different images, therefore it is 1 1. But all the elements of the codomain are not image here. 7 is not image here. Therefore it is not auto. It is very simple. Okay. Now here I write here all the elements of A are all the elements of A having different images. Therefore F is 1. Okay. All the elements of codomain are not images, images. Therefore, F is not onto. F is not onto. Okay. But here, so you don't supposed to write this. Just have to take here. 1, 2, 3 are the elements of domain that have different images. One has 4, 2 has 5, 3 has 6. All the elements of A having the different images. Therefore, F is 1, 1. All the elements of codomain are not images. All the elements are not. Some elements are only the images here. 7 is not image here. Otherwise here, instead of this, 7 belongs to the codomain. In codomain, 7 is not image. It is the better point. Here, 7 that is in codomain. In codomain, here I write instead of this is the best. Here, in codomain, the element 7 is not image. Therefore, F is not on. Therefore, F is not on. This is the best thing. Right? This is the case. So, here it is 1, 1 onto like this. Right? It is very clear. Ali, first set, second set. But ಇಲ್ಲಿ consolidate ಮಾಡಿ ಒಂದು ಫಂಕ್ಷನ್ ಅನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಫಸ್ಟ್ ಸೆಟ್ ನಲ್ಲಿ ಇರೋ ಎಲಿಮೆಂಟ್ ಗೆ ಡಿಫರೆಂಟ್ ಇಮೇಜಸ್ ಇದೆಯಾ, ಸೇಮ್ ಇಮೇಜ್ ಇದೆಯಾ, ಸೊ ಅದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಅದನ್ನ ಆನ್ಸರ್. Here I take two questions. So first question, here state whether the function is 1, 1 or onto or bijective. So we know that when it is bijective, if the function is injective and surjective. I mean if the function is 1, 1 and onto, then it is said to be a bijective function. Okay. Now here I take R tends to R. R tends to R defined by f of x equals 3 minus 4x. R tends to R means we can take all numbers, integers, natural numbers, integers, rational numbers. We can take all numbers here. Now here f of x equals 3 minus 4x. Now listen here. F of A equals f of B. Now here 3 minus 4A is equal to 3 minus 4B. Just I have to substitute the A value here, left hand side. In right hand side I have to substitute that B value. Now here, just here 3 will cancel. 3 to shift the right hand side, then that will become minus 3 plus 3 minus 3 will become cancel. Now here it is 4A is equal to 4B and 4 will cancel. So it is A is equal to B. A equal to B. Therefore, F is 1, 1. F is 1. F is 1. Okay. Now I take for B is equal to f of A. B equals f of A. B equals f of A means 3 minus 4A. 4A to here. 4A plus B is equal to 3. Shift B to here. 4A is equal to B minus 3 minus B. 3 minus B. Then A is equal to 3 minus B divided by 4. 3 minus B divided by 4. Actually here, if you substitute any value here, you will get either integer, either natural number or rational number. Totally here somewhere it is not belongs to Z. Somewhere it not belongs to natural numbers, but it belongs to real numbers. I mean it belongs to rational numbers. Q, it belongs to Q. But Q which belongs to R. Therefore A, so which belongs to R. Therefore F is onto. F is onto. Therefore it is which is the, I mean all the elements of the codomain are images. Therefore, f is 1, 1 and f is onto. Therefore, f is bijective. F is bijective. For this 3 minus 4x, it is 1, 1 and onto. For r tends to r tends to r for 1, 1 and onto. Therefore, f is bijective. Now, here I will come into the second question. Here, f. So, as r tends to r, define f of x equals 1 plus x square. Now, listen to me here. F of x equals 1 plus x square. x square ಬಂದ ತಕ್ಷಣ ಆ x square ಜೊತೆಗೆ 1 plus ಅಂತ ಇರಲಿ 2 minus ಅಂತ ಇರಲಿ x square minus ಅಂತ whatever it is x square ಅಂತ ಬಂದ ತಕ್ಷಣ n tends to n ಅಂದ್ರೆ ಮಾತ್ರ ಅದು 1 1 ಆಗುತ್ತೆ. Otherwise it is not 1 1, it is not onto. Now here I take f of a equals f of b. Now here 1 plus a square is equal to 1 plus b square. Now here a square is equal to b square. 1 1 cancel ಆಗುತ್ತೆ. A is equal to plus or minus root of b square. That is a is equal to plus or minus b. I mean plus b minus b minus b. Both have a here. Therefore, f is not 1 1. F is not 1 1. Now here b is equal to f of a. B equals f of a 1 plus a square. Now here b minus 1 is equal to a square. A is equal to plus or minus root of b minus 1. But here b minus 1 it not belongs to r, because here somewhere here root of minus 6 root of minus 5 not belongs to r. Therefore, f is not onto. F is not onto. Illi b minus 1 anta somewhere. Suppose here, if you take b here 0. If you take 0 here, 0 minus 1, then it is minus 1. Suppose here minus 4. What is minus 4 minus 1? Minus 5. Root of minus 5 not belongs to r. Therefore, it is not onto. Therefore, this function is neither 1 1 nor onto. Totally 1 1 onto. Same position node, but yav set alli tagotivi. N tends to n, r tends to r, z tends to z. Adanna nodkondo answer madu. Okay? If you take any number here, whatever it is, if you take any number here, square anta bandaga illi namge, then here we take plus or minus. Here if you take f of minus 1 here, f of minus 1 plus 1 2, f of 1 2. Two different images, two different elements of the domain have the same image. But in that case, there also same thing, but all the elements are not images. Not here actually. If you take that here, in case 1 plus x square, here actually root of b minus 1. If you have that b as minus 5 minus 1 minus 6, it is not the image. Okay, so f is not 1 1 and not on, neither 1 1 nor on.